In this lecture, let's discuss on some of the most important Python concepts. In this video, I will cover Python identifiers and what are variables and how to use them, and what are the different operators that are supported in Python and the keywords that are available in Python. Let's begin with the concepts now. Let's first understand what are Python identifiers. So the Python identifier is the name given to entities like class, functions, variables, etc. In Python, it helps differentiating one entity from another. So basically, when you create a variable or when we create a class or a function, we basically use the name. So those names are called as an identifiers. So there are basic rules for writing an identifier. Let's understand one by one. So the first point is, identifiers can be a combination of letters in lowercase or uppercase, or digits or an underscore. These are all valid identifiers in Python. An identifier cannot start with a digit. This is invalid in Python because this particular identifier is starting with a number. But this is perfectly fine because the number is used at the end of the identifier. Keywords cannot be used as identifiers. There are a set of keywords that are supported by Python, so we should not use those keywords while we are creating an identifiers. As we can see here, using keywords as a variable will throw an error. Since global is a keyword, this will throw error. We cannot use these special symbols in our identifiers. Suppose if we use any of these special symbols in our identifier, this will throw an error. As we can see here, using any of these symbols in variable will throw error. And identifiers can be of any length. Suppose if the identifier is a multi-worded identifier, then they must be separated by using underscore. So these are the basic rules that we have to follow while creating an identifiers. Let's understand some of the things that are important while we are creating an identifier. Python is a case-sensitive language. This means these two are not same because this particular identifier is having the first letter which is in capital and this variable which is having the first letter in the smaller case. Hence, these two variables are not same because Python is a case-sensitive language. Use meaningful names for the identifier. While c is equal to 10 is valid, writing count is equal to 10 would make more sense and it would be easier to figure out what it does even when you look at your code after a long time. So as I have already mentioned, if the variable is multi-worded, multiple words can be separated using an underscore. This is an identifier with multiple words. As we can see here, the words are separated by using underscore. We can also use camel case style of writing, that is capitalize every first letter of the word except the initial word without any spaces. For example, and this is how we can represent an identifier using the camel case style. That's all about an identifier. Now let's understand what are Python variables and how to use them in our programming. In most of the programming languages, a variable is a named location used to store data in the memory. Each variable must have a unique name called identifier. It is helpful to think of variable as container that hold data which can be changed later throughout programming. Variables are nothing but reserved memory locations to store values. This means that when you create a variable, you reserve some space in memory. Based on the data type of a variable, the interpreter allocates memory and decides what can be stored in the reserved memory. Therefore, by assigning different data types to variables, you can store integers, decimals, or characters in these variables. So in Python, we don't assign values to the variables, whereas Python gives the reference of the object to the variable. Let's understand how to declare variables in Python. In Python, variables do not need declaration to reserve memory space. The variable declaration or variable initialization happens automatically when we assign a value to a variable. So the Python variables do not need explicit declaration to reserve memory space. The declaration happens automatically when you assign a value to a variable. The equal sign is used to assign values to variables. The operand to the left of the equal operator is the name of the variable, and the operand to the right of the equal operator is the value stored in the variable. For example, here, in these examples, 100, 1000.0 and John are the values assigned to counter, miles and name variables respectively. This produced the following result. So Python is a type inferred language. It can automatically infer, that is, it can know automatically what is the data type that is associated to a variable. Type inference refers to the automatic detection of the data type of an expression in a programming language. Multiple assignment is also possible in Python. So the Python allows us to assign a single value to several variables simultaneously. For example, here we are assigning an integer object, that is 1, to 3 variables simultaneously. Here in this case, an integer object is created with the value 1 and all 3 variables are assigned to the same memory location. So we can check whether all the variables are pointing to the same object using an ID built-in function. We can also assign multiple objects to multiple variables. For example, here 2 integer objects with value 1 and 2 are assigned to variables a and b respectively, and 1 string object with the value John is assigned to the variable c. As we can see in the output, the a is assigned with 1, b is assigned with 2 and c is assigned with John. So let's understand how to do swapping of 2 variables in Python. Swapping basically means interchanging values. So to swap Python variables, you don't need to do much. As we can see here, initially we are associating 2 string objects 1 and 2 to the variables a and b respectively. In order to swap the 2 variables, you can just mention that a comma b is equal to b comma a. Here in this case, the value of b will be assigned to a and the value of a will be assigned to b. So in this way, we can swap the 2 variables in Python. As we can see in the output, the values of a and b are swapped after executing this particular program. So that's all about swapping variables. Now let's understand what are the standard data types that are supported and how we can assign those data types to a variable. The data stored in memory can be of many types. For example, a person age is stored as a numeric value and his or her address is stored as alphanumerical characters. Python has various standard data types that are used to define the operations possible on them and the storage method for each of them. Predominantly, Python has 5 standard data types. They are numbers, strings, list, tuple, and dictionary. Let's understand them one by one. Let's begin with understanding how to use numbers in Python. Python supports integers, floating point numbers, and complex numbers. They are defined as int, float, and complex class in Python. Integers and floating points are separated by the presence or absence of a decimal point. 5 is integer, whereas 5.0 is a floating point number because there is a decimal point associated with 5.0. Complex numbers are written in the form of x plus yj, where x is the real part and y is the imaginary part. We can use the type built-in function to know which class a variable or a value belongs to, and isInstance function to check if it belongs to a particular class. So number data types store numerical values. Number objects are created when you assign a value to them. Let's understand this with an example. Here variable var1 and var2 are created, which are holding integer object 1 and 10 respectively. This is how we can assign an integer object to the variable. Here I have created one more variable a, which is holding an integer object 5. This will return class int because a is belonging to a class integer. And this will return float because the 5.0 is a float object. And this will return complex because the 8 plus 3j is the complex representation and it is belonging to class complex. IsInstance function basically accepts two arguments, where the first argument is an object and the second argument is a class. So this will return true because the first argument, which is an object belonging to a class complex. Suppose if the second argument is anything apart from complex, this will return false. This is how we can check whether a specific object is an instance of a specific class or not. So Python predominantly supports 4 different numeric types. They are int, long, which are basically long integers. They can also be represented in octal and hexadecimal format, and the floating point real values and the complex numbers. Let's understand them with an example. Python allows us to use a lowercase l with long, but it is recommended to use only an uppercase L to avoid confusion with the number 1. Python displays long integers with an uppercase L. Python can hold the integers of any length. The only limitation is the memory of the system. The long integers are represented by using an uppercase letter L. A complex number consisting of an ordered pair of real floating point numbers denoted by x plus yj, where x and y are the real numbers and j is the imaginary unit. While integers can be of any length, a floating point number is accurate only up to 15 decimal places. The 16th place is inaccurate. Numbers we deal with every day are decimal, that is base 10 number system, but the computer programmers need to work with a binary, that is base 2, or hexadecimal, which is base 16, and octal, that is base 8 number systems. In Python, we can represent these numbers by appropriately placing a prefix before that number. The following table will explain how to represent the number in binary, hexadecimal and octal number systems. As we can see in the table, so this is how we can represent the binary number, and this is how we can represent a octal numbers, and this is how we can represent an hexadecimal number. So let's understand this with an example. Here in this example, so this is how the binary representation of the number 107 is represented. And this is how an hexadecimal plus binary numbers are represented. As we can see in the output, the hexadecimal and the binary numbers representation got converted into a number representation, which is base 10. This is how a number can be represented using octal number system. That's all about the Python numbers. Now let's understand how to use Python strings. The strings in Python are identified as a contiguous set of characters represented in the quotation marks. Python allows for either pairs of single or double quotes. Subsets of strings can be taken using the slice operator, that is square brackets, with indexes starting at 0 in the beginning of the string and working their way from -1 at the end. The plus sign is the string concatenation operator and the star is the repetition operator. So let's understand the strings with an example. Here I have created a variable str which is holding a string hello world with an exclamation. Here in this example, this will fetch the character at the 0th index. As we can see in the output, this have extracted the character at the 0th index. And in this example, this will fetch the range of characters from the second index till fifth index, that is excluding the character at the fifth index. As we can see in the output, this have extracted a range of characters from the second index till fifth index. So this will fetch the range of characters from the character at second index till the last index. In this case, the character at the last index is also included. So this will perform the repetition. As we can see in the output, this will print the value of the string str 2 times because we are performing a repetition for 2 times. And this will perform the concatenation. As we can see in the output, the test is appended to the string str. This is how we can use strings in Python. Now let's understand how to use lists in Python. Python lists are the most versatile of Python's compound data types. A list contains items separated by commas and enclosed within square brackets. To some extent, lists are similar to arrays in C. The one difference between them is that all the items belonging to a list can be of different data type, whereas the element in arrays are of same data type. The values stored in a list can be accessed using the slice operator, that is brackets, with indexes starting at 0 in the beginning of the list and working their way to end -1. The plus sign is the list concatenation operator and the star is the repetition operator. Let's understand the Python list with an example. Here I have created two lists with the name list1 and list2, where list1 holding 5 elements of different data types and the list2 is holding the 2 elements of different data types. So in this example, this will print the complete list, and here in this example, this will fetch the element at index 0 since the index of the list starts from 0. As we can see in the output, this will fetch the element at the index 0, that is the first element in the list. In this example, this will extract a range of elements from the list, list1. As we can see in the output, this have extracted the elements from the first index till the third index and excluding the element at the third index. And this will extract the elements of a list, list1, from the second index till the last index. In this case, the element at the last index is also included in the output. In this example, this will perform the repetition. As we can see in the output, the list2 is repeated twice. Here, this example have performed the concatenation because the plus operator in the list will perform the concatenation. As we can see in the output, the elements of the list1 and list2 are concatenated in this example. So that's all about the Python list. Now let's understand what are Python tuples. A tuple is another sequence data type that is similar to the list. A tuple consists of a number of values separated by commas. Unlike list, however, tuples are enclosed within parentheses. The main difference between list and tuples are the lists are enclosed in brackets and their elements and size can be changed, while tuples are enclosed in parentheses and cannot be updated. So tuples can be thought of a read-only list. So let's understand the tuples with an example. Here I have created two tuples, tuple1 and tuple2. So tuple1 is created with 5 elements, which consisting of elements of different data type, and the tuple2 is another tuple which is created with the 2 elements. So this will print all the elements of the tuple1. Since the index of the tuple starts from 0, this will fetch the first element of the tuple, that is at the 0th index. So we can also fetch the range of elements from the tuple using the concept of slicing. This will fetch the range of elements starting from index 1 until the index 3, but excluding the element at the index 3. And here in this example, this will fetch the element starting from the index 2 till the last index of the tuple. But in this case, the element at the last index is also included in the final result. So we can use the star operator in order to perform the repetition of a tuple. Here we are using a star operator to print the tuple 2 times. As we can see in the output, in this case, the tuple 2 is printed twice in the output. And also we can use the concatenation operator, that is place, in order to perform the concatenation on 2 tuples. As we can see here in this example, we are trying to concatenate 2 tuples, tuple 1 and tuple 2. As we can see in the output, the tuple 1 and tuple 2 are concatenated. The following code is invalid with tuple because we attempted to update a tuple which is not allowed. Similar case is possible with a list. As we can see in this example, this will not result in an error because since list is mutable, meaning the length of the list can be updated as well as the element of the list can be updated, this will not result in an error. But in this case, we are trying to update the element of the tuple. Since tuples are immutable, meaning the length of the tuple cannot possible to update as well as the element of the tuple is not possible to update, this will result in error. As we can see in the output, this particular example has ended with an error because the tuple is immutable. That's all about tuples. Now let's understand how to use another important data structures in Python, that is dictionaries. Python's dictionaries are kind of hash table type. They work like associative arrays or hashes found in Perl and consisting of key value pairs. A dictionary key can be almost any Python type, but are usually numbers or strings. The values, on the other hand, can be any arbitrary Python object. Dictionaries are enclosed by curly braces, and values can be assigned and accessed using the square brackets. Let's understand dictionaries with an example. Here in this example, so this is an empty dictionary since no items present inside the curly braces. So this is how we can add an item to an existing dictionary. Here 1 is a key and this will be the value associated to the key. And here in this example, the 2 will become a key and this will become a value associated to the key 2. We can also create a dictionary with a key value pair like this. So here in this example, this is going to print the value of the key 1 associated with the dictionary dict1. As we can see in the output, this particular example have yielded the value which is associated with the key 1. Here in this example, this will yield the value associated with the key 2. Here in this example, this will fetch the complete dictionary that is associated with the variable dict2. We can also use inbuilt methods such as keys and values to fetch all the keys associated with the dictionary using keys method and all the values associated with the dictionary using the values method. So dictionaries have no concept of order among elements. It is incorrect to say that elements are out of order. They are simply unordered. So till now we have understood how to use the variables. What are the different data types can be associated with the variables. Now jump into the next important concept, that is Python operators. So the operators are the constructs which can manipulate the value of operands. So consider the expression 4 plus 5 is equal to 9. Here 4 and 5 are called operands and plus is called operator. Python language supports 7 different types of operators. They are arithmetic operators, comparison or relational operators, assignment operators, logical operators, bitwise operators, membership operators, and identity operators. Let us have a look on all operators one by one and see some examples that are associated with each operators. So let's start with Python arithmetic operator. So these are the different Python arithmetic operators that are supported in Python. So let's understand all these operators with an example. So initially I have created three variables with a, b and c respectively. A is holding the integer value which is 21 and b is holding 10 and c is holding 0. So let's understand how we can use arithmetic operators in Python. So let's start with an addition operator. So addition operator adds values on either side of the operator. As we can see here, so c will be assigned with the value which is a sum of two operands a and b, where plus is an operator. Subtraction operator, that is minus, will subtract right hand operand from left hand operand. As we can see in this example, so this have extracted the value which is a result of subtraction that is performed on the right hand operand from left hand operand. The multiplication operator, that is a star, will multiply values on either side of the operator. As we can see in this example, this have yielded the product of two operands a and b. So the division operator will divide the left hand operand by right hand operand. As we can see in this example, this have yielded the result which is an outcome of division that is performed on left hand operand by right hand operand. This is a modulus operator. It will divide the left hand operand by right hand operand and returns the remainder. As we can see in this example, this will perform a division on the left hand operand by the right hand operand, and as we can see in the result, this have returned the remainder after performing the division. So this is a floor division. So the floor division is the division of operands where the result is the quotient in which the digits after the decimal point are removed. But if one of the operands is negative, the result is floored, that is rounded away from the 0, that is towards negative. As we can see in this example, so the left and right operands are the positive integers, and hence as we can see in the output, the result is the quotient in which the digits after the decimal point are removed. But in this case, since the left operand is minus, we can see in the output the result is floored, that is rounded off away from 0, that is towards negative. So this is how we can use the Python arithmetic operators. Now let's understand how to use Python comparison operators. So the Python comparison operators compare the values on either sides of them and decide the relation among them. So they are also called as an relational operators. These are the different comparison operators that are supported in Python. So let's understand them with an example. Here I have created three variables a, b, c, which is holding 21, 10 and 0 respectively. So let's understand how to use an equal operator. So this is how we can use the equal operator. If the values of two operands are equal, then the condition becomes true. As we can see in this example, this particular piece of code will be executed if a equals to b. If a is not equal to b, then the else block will be executed in this particular piece of code. As we can see in the output, since a is not equal to b, so this particular piece of code will be skipped and the else code will be executed, as we can see in the output. So this is how we can use not equal operator. If the values of two operands are not equal, then condition becomes true. As we can see in this example, since a is not equal to b, this condition becomes true and hence the if block code will be executed, as we can see in the output. Hence if block code will be executed. We can also use this particular operator which does the same task as not equal to operator. So here in this case, if values of two operands are not equal, then condition becomes true. So this is the greater than operator. So if the value of the left operand is greater than the value of the right operand, then the condition becomes true. As we can see in this example, since the value of a is greater than the value of b, so the if block code will be executed. Similarly, we can use the less than operator. If the value of the left operand is less than the value of the right operand, then the condition becomes true. As we can see in this example, since A is not less than B, this condition will be evaluated to false, and hence the else block code will be executed in this case. So this is a greater than or equal to operator. If the value of left operand is greater than or equal to the value of the right operand, then the condition becomes true. Here in this example, since the A is greater than B, the if code will be executed. Similarly, we can use less than or equal to operator. If the value of left operand is less than or equal to the value of right operand, then the condition becomes true. So that's all about Python comparison operators. Now let's understand Python assignment operators. These are the different assignment operators that are supported in Python. Let's understand these operators with an example. This is an equal operator, so this will assign the values from the right side operand to the left side operand. Here in this example, the sum of the two operands, that is A and B, and the result will be assigned to the variable C. So this is add and assignment operator. So what it does is it adds right operand to the left operand and assign the result to the left operand. So this is equivalent to C is equal to C plus A. Similarly, we can use subtract and assign operator. So this will subtract the right operand from the left operand and assigns the result to left operand. So this is equivalent to C is equal to C minus A. This is multiply and assign operator. So what it does is it multiplies the right operand with the left operand and assign the result to left operand. This is equivalent to C is equal to C star A. Divide and assignment operator will divides the left operand with the right operand and assign the result to the left operand, and this is equivalent to C is equal to C divided by A. So the modulus and assign operator, it takes the modulus using two operands and assign the result to the left operand, and this is equivalent to C is equal to C modulus of A. And exponent and assign operator performs the exponential calculation on operators and assign value to the left operand, and this is equivalent to C is equal to C exponential A. This is floor division and assign operator. So what it does is it performs the floor division on the operators and assign value to the left operand. This is how we can use the assignment operators in Python. Now let's understand how to use Python bitwise operators. Bitwise operators works on bits and performs bit by bit operation. As we already know that computers can only understand ones and zeros, so everything has to be converted into ones and zeros before processing. So assume if A is equal to 60 and B is equal to 13, in the binary format we can actually represent like this. This is a binary AND operator. So this operator copies a bit to the result if it exists in both operands, otherwise it will copy 0. And this is binary OR operator. It copies a bit if it exists in either operand. If it exists in any of these operands, then 1 will be copied, otherwise the 0 will be copied in the result. So this is an binary XOR operator. It copies the bit if it is set in one operand but not both. And hence, as we can see in this example, this will return 1 since it is set in one operand, but if both operand are set, then the 0 will be returned. So this operator will perform binary ones complement. It is unary and has the effect of flipping bits, as we can see in the output. So here in this case, so 1 will become a 0 and the 0 will become 1. So this is binary left shift operator. The left operand's value is moved left by the number of bits specified by the right operand. As we can see in this example, so A is a variable which is holding a binary bits, and we are mentioning to shift the bits towards the left side for 2 positions, and hence we can see in the output the bits in the A variable has been moved left by the number of bits specified by the right operand. Similarly, we can use binary right shift like this. In this case, the left operand's value is moved right by the number of bits specified by the right operand. As we can see in the output, in this example, the left operand's value is moved right by the number of bits specified by the right operand. So that's all about the Python bitwise operators. Python also supports some of the logical operators, and these are the logical operators that are supported by Python. Let's understand this with an example. Let's assume that the variable A holds 10 and B holds 20. This is a logical AND operator. If both the operands are true, then conditions become true. As we can see in this example, so this will return into true because both operands A and B is resulting in true. In case of logical OR operator, if any of the 2 operands are non-zero, then conditions become true. So this will result in true because the 2 operands are non-zero in this case. Not logical operator used to reverse the logical state of its operand. As we can see in this example, A and B will result in true, and logical NOT will reverse the logical state of its operand, and hence this will return in false. Basically, the logical NOT is used to reverse the logical state of its operands. So that's all about the logical operators. Python also supports membership operators. Python's membership operators test for membership in a sequence, such as strings, lists, or tuples. There are 2 membership operators that are supported in Python. The first operator is in operator, which evaluates to true if it finds a variable in the specified sequence and false otherwise. This is the general syntax for the in operator. So y may be any sequence. If the element x is present in y, then it will return true. Suppose if you are using a string, if y is a string, if the x character is present in y string, then this will return true. The second membership operator is not in, which evaluates to true if it does not finds a variable in the specified sequence and false otherwise. This is basically negates the result of in operator. So this is the general syntax. We can use it for not in operator. Suppose if the element x is not present in y, then it will result in true. Suppose if it is a string, if the character x is not present in the y string, then this will return true. As we can see in these examples, so this will return true if the element A is present in the list. If it is not present in the list, then it will return false. Similarly, if you are using a strings, if the character is present in a string, then it will return true, else it will return false. Similarly, we can use not in operator in order to check whether the element or a character is not present in a list of strings. So that's all about the membership operators. Now let's understand the last operator that is supported in Python, that is an identity operator. So there are 2 identity operators that are supported by Python. So the first operator is operator, which evaluates to true if the variables on either side of the operator point to the same object and false otherwise. So this is the general syntax. Suppose if the object x is same as the object y, then it will result in true. Suppose if the x object is not same as the y object, then it will return false. So basically we can check the object ID by using an ID built-in function. Suppose if the ID of x is same as the ID of y, then this expression will be evaluated to true, otherwise it will be evaluated to false. Similarly, we can use is not operator in order to check whether the x object is not same as the y object. So this will evaluate to false if the variable on either side of the operator point to the same object, and true otherwise. This is the syntax. So this particular expression will return true if the object x is not same as the object y. Suppose if the object x is same as the object y, then it will return false. So this is how we can use the different types of operators that are associated with the Python. Now let's understand one more important topic that is associated with the operators, that is operators precedence. Following table lists all operators from highest precedence to the lowest precedence. Suppose if the expression consisting of mixture of many operators, then the evaluation of the expression happens on the basis of the operator precedences. If there is an exponential operator present in an expression, then that will be given an highest priority, and if there is an logical operators are present in the expression, then they will be given the last priority in the expression. Make a note of this precedence table. This will help you to evaluate the expression when your expression is lengthier. Operator precedence affects how an expression is evaluated. Let's understand this with an example. In this example, x is equal to 7 plus 3 star 2. Here x is assigned with the 13, not 20, because as we can see in the table, operator star has highest precedence than plus, so it multiplies 3 star 2 and then adds into 7. So here the operators with the highest precedence appears at the top of the table, those with the lowest appear at the bottom. In this way, any lengthier expressions can be evaluated seeing the precedence of an operator with the reference of this particular table. That's all about the operators. Now let's understand what are the different keywords that are supported in Python. So keywords are the reserved words in Python. So we cannot use a keyword as variable name, function name, or any other identifiers. They are used to define the syntax and structure of the Python language. Suppose if we use any of the keywords as a variable or a function name or a class name, then Python interpreter will throw an error. In Python, keywords are case sensitive. There are 33 keywords in Python 3.3. This number can vary slightly in different versions. So all the keywords except true, false, and none are in lowercase, and they must be written as it is. So this is the list of all the keywords that are supported in Python. So the above keywords may get altered in different versions of Python, as I have already mentioned. Some extra might get added or some might be removed. You can always get the list of keywords in your current version by typing the following in your command prompt. First of all, we have to import a module, that is a keyword module. Here in this case, this will import keyword module, and this will return the list of keywords that are supported in the current version of the Python. KWList is a attribute that is associated with the module keyword. This will fetch the list of all the keywords that are supported in the current version of the Python. And I will explain all these keywords when and where it is necessary. In this video, we have understood what are identifiers and how to use variables in Python, and what are the different keywords that are supported in Python. So that's all for this video. Let us know if you have any questions. Thanks for watching. Let's meet in the next video. Thank you.